Explaining magnetism with the domain theory. Imagine a factory somewhere that makes little bar magnets and ships them out to schools for their science lessons. Picture a guy called Dave who has to drive their truck, transporting lots of cardboard boxes, each one with a magnet inside, to a different school. Dave doesn't have time to worry which way the boxes are stacked, so he piles them inside his truck any old how. The magnet inside one box could be pointing north, while the one next to it pointing south, east, or west. Overall, the magnets are all jumbled up, so even though the magnetic fields leak out of each box, they all cancel one another out. The same factory employs another truck driver called Bill, who couldn't be more different. He likes everything tidy, so he loads his truck a different way, stacking all the boxes neatly so they line up exactly the same way. Can you see what will happen? The magnetic field from one box will align with the field from all the other boxes, effectively turning the truck into one giant magnet. The cab will be like a giant North Pole, and the back of the truck a huge South Pole. What happens inside these two trucks is what happens on a tiny scale inside magnetic materials. According to the domain theory, something like an iron bar contains lots of tiny pockets called domains. Each domain is a bit like a box with a magnet inside. See where we're heading? The iron bar is just like the truck. Normally, all its onboard boxes are arranged randomly, and there's no overall magnetism. The iron is not magnetized. But arrange all the boxes in order, make them all face the same way, and you get an overall magnetic field. Hey, presto, the bar is magnetized. When you bring up a magnet to an unmagnetized iron bar and stroke it systematically and repeatedly up and down, what you're doing is rearranging all the magnetic boxes or domains inside so they point the same way. This is unmagnetized because all of the domains are pointed different ways, and this is magnetized because all of the domains are pointing one direction. Down here the caption says, domain theory explains what happens inside materials when they are magnetized. In an unmagnetized material on the left, the domains are randomly arranged so there is no overall magnetic field. When you magnetize a material, as shown on the right, by stroking a bar magnet over it repeatedly in the same direction, the domains rearrange so their magnetic fields align, producing a combined magnetic field in the same direction. This theory explains how magnetism can arise, but can it explain some of the things we know about magnets? If you chop a magnet in half, we know you get two magnets, each with a north and south pole. That makes sense according to the domain theory. If you cut a magnet in half, you get a smaller magnet that's still packed with domains, and these domains can be arranged north-south, just like in the original magnet. What about the way magnetism disappears when you hit a magnet or heat it? That can be explained too. Imagine the van full of orderly boxes again. Drive it erratically, that means side to side and turning quickly at really high speed, and it's a bit like shaking or hammering it. All the boxes will jumble up so they face different ways, and the overall magnetism will disappear. Heating a magnet agitates or disturbs it internally inside and jumbles up the boxes in much the same way. So this material would not be magnetic. They say it's unmagnetized because the domains are all pointing different ways and cancel each other out. They can't make a magnetic field. In this example, all the domains are pointing one way, and you can see they're organized, and then the magnetic field can form.